Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 428, minimum operations to make character frequencies equal. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about, well, this problem and this contest and everything in between. Yeah, not many people solved this one, it turns out, but I was very fortunate to be able to solve it. There are a couple of things about this one. The first thing is that goes to 2 times 10 to the 4th or 20,000, right? So you know that from that n squared is not going to be good enough. There are a couple of observations to make about this problem that I did, and I guess I did it very quickly, relatively. Only about, well, maybe not that quickly, but still quickly enough. Is that, well, I didn't know if there were optimizations that I could have made later, but some of the, and I'm just explaining my thought process because I think sometimes it's more interesting than actually just, like the solution you could get anywhere else, right? But my thought process was, okay, let me play around with this. If it doesn't work, at least I'll get a wrong answer to kind of tell me what's good, right? Because for this one, I really didn't have a good, like I didn't know what it was immediately. But the key thing is just, there are a couple of key things. One is that I'm like, okay, 20,000, what if we brute force try 20,000, right? For the result. It's almost like a binary, like, it's not binary search, but there are problems where you binary search for the answer. But it's kind of like that, except for you linear search for the answer. And that's basically what I did. I just linear search, okay. If all the characters, and there's only 26 characters, right? Step back a second. There are only 26 characters, and the characters' orders don't matter. So it's just about the count of the number of characters, so that makes it a little bit easier to maintain. But as a result of that, because there are only 20,000 characters, then each character can only appear, well, at most 20,000 times, and even then, obviously, that's not the worst case. But if you just try 0, 1, 2, 3, 4, 5, 6, all the way down to 20,000, and then we are good, right? That's part one. But the second thing is that the check part has to be fast, right? If you're doing 20,000 times 20,000 again, that'll be too slow. But fortunately, we are able to kind of solve this with dynamic programming. So here's my, I also I did this after the contest because I wasn't sure if it would kind of make it a little bit better. It didn't actually change that much, so you could ignore it. But first I convert it to from a character to an int. That's basically the idea, right? Just from 0 to 25, so I can work with it a little bit easier. And then I do a collection.counter. That is, it just sets up the frequency table. I don't know why I use C, I guess for counter, because usually I use F for frequency. But in any case, yeah. And max value is just, well, it never makes sense to add characters, like if your character appears, if your max character appears max times of 5, it doesn't make sense to test for 6 because then you're adding characters to everything, which doesn't make sense, right? So you could kind of figure it that way. It's an easy proof, so you can do it. But I do that, and after I do that, I just do a for loop. I try 0, 1, 2, 3, 4, 5, ... all the way to max inclusive, right? And I have this function called go_sub_i. And go_sub_i is, actually not the dynamic programming thing. It's just terrible, lazy naming, which is, I was focusing on the problem. It just sets up, okay, this is the target, right? So what if we try to get all characters to target, right? And that's basically it. And then now we have this dynamic programming function where, I'll go with the dimensions, but it's just, we have index, which is technically it goes from 0 to 25, which is actually just A to Z. But I like to deal with numbers so that I could add 1 and stuff like this as Y. I guess I'll just leave it here. And leftovers. So the thing I noticed for leftovers is that you can change a character from S to the next character in the alphabet, right? So as a result, I just call them leftovers so that if you upgrade, then now it's next index problem, right? So previously upgraded characters, right? The number of them. Only the number matters, right? So you have like 5B and you didn't need 3 of the B's, then that's what you would go to. And then at this point, it is just case analysis. But there is one additional observation that you can make. The key observation that I think I took for granted a little bit, but I am noticing, is that is that you look at these three operations, right? Well, if you could change a character, and remember, you can only go up and not down, right? So if you change S to the next character, well, what happens if you change it twice, meaning from A to B and then B to C? Well, that is equivalent to deleting and then inserting, right? Deleting an A and then inserting a C. So that means that, and this is a tricky observation. I mean, it's maybe obvious once you see it and how it fits together, but that is the key observation, right? Is that you always only upgrade once. Or that's the way to kind of make this optimization. And why does that matter as an optimization? We'll go over in a sec. But that's kind of the assumption in my code that I do. That if you just look at the code, it may not come out, or you may be like, "What is Larry doing?" Right? And that's basically the idea. If current is equal to target, we just go to the next one, right? Straightforward. I mean, we've already done. We just go to the next index, right? And then, but here I said leftover is 0. Why? Why does it? We just ignore leftovers and go to 0. Well, the thing is that if we have leftovers and we are trying to get, it's equivalent as inserting, and the cost for deleting is the same as having one leftover, right? So what that means is that, and I hope I'm saying it right, correctly, because it is a hard concept to get, but it's just that, okay, so the cost here in other functions, which we'll talk about later, factors in the fact that we're upgrading. So I'll talk about it again in the upgrade, but yeah, okay. So let's just pretend that we can throw away these leftovers, because if the future needs it, they could have just inserted themselves, because then the alternative may be, if you want to think about it more directly, you may be like leftovers plus leftovers, because you have to take all the leftovers and then add it to the next step. But you don't even know if you're going to use them, so it doesn't make sense in that way, right? Because this may be the way to kind of think about it. But again, and then now, if you had this, you have to think about, well, how many leftovers should we keep? And then maybe you even have to do a for loop, which is just nuts, right? So anyway, but we do not have to do it, because again, if we have to upgrade twice, meaning that we have to carry the leftover twice, we should have just deleted and then inserted. So that's basically the idea for this part. Okay. And remember, I'll talk about it when I get to upgrade, I suppose. Let's go to delete. Delete is pretty straightforward. If current is greater than target, right, then we want to get from current to target. Again, same logic with the leftovers. We'll talk about it in a sec, or in the future. And this is the cost, right? Because if we have 5 A's, we're trying to get to 2 A's. It just costs, you just have to remove 3 A's. Straightforward. And this is to delete it to 0, right? Yeah. Maybe I'll write it. Delete to 0, right? And that's also relatively straightforward. I think the cost, where you have 5 A's, and maybe your target is 10 A's or 11 A's, so you just go from 5 to 0 and then check it. So that's basically this constraint, right? Delete to 0. And insertion is also relatively maybe straightforward. If it's fewer than target, then we just try to get the target, and that is just this math, right? You just do the math on the delta, and then you just and then delta will figure it out again. But this time though, we do use the leftovers. This is the only time we use leftovers, because with that we don't have to insert more, right? So that's basically the idea for this one. And you could kind of use an example, right? Because if you have 5 A's, or A's is, well, there's no leftovers for A's, but let's say you have 5 B's, you're trying to get to 10 B's. If you have 3 A's that were upgraded, then you could use them. Makes sense? If you have too many, obviously you have to kind of then you can you use all of them, or all that you can. You have extra leftovers which we throw away. Again, we'll talk about the throw away in a sec, but that's the insertion, right? And then this is the key part, upgrade. Let's do this one first, just because. Okay, so this is upgrade all of them so that we have 0 of the current character, right? So that's basically what this is saying. We upgrade all of them, so we have current as leftover. Remember that we don't care about the previous leftovers, because if we have to upgrade twice, it already is too expensive, right? Or you could just insert and delete. And the reason why we already add and that's the key thing, is that we add the cost here because this is the cost of the upgrade. But also, one thing to note is that this cost is the same as deleting cost, right? Right? But what I mean by that is that this cost is the same as this cost. That means that they're effectively the same and you get the leftovers for free. You may even kind of, if you really want to be adventurous, you could probably like maybe figure out a way to, you can actually like, I think now that I see it this way, right? Because, you know, I separate out the delete and upgrade for maybe like enumeration reasons. I didn't optimize this. Actually, I guess I could optimize this, because if you kind of look at, like this is strictly worse than this, I think, right? So we'll optimize it in a sec, but that's the idea, right? But yeah, so that means that we can treat this as a delete with, we could treat it as a delete with a free upgrade, right? Meaning that the next characters have free characters. Maybe leftovers is a weird way of phrasing it, but next characters have them for free because you already paid for them, but you only paid for it for one character upgrade. Meaning from, if you have 10 Bs, you only pay for them to go to Cs, not Ds, right? Because if you, otherwise you could treat them as deleting them with the free upgrade. So maybe another way to think about it is that upgrade is equal to delete with X, whatever X could be, free upgrades for the next and only next character. So that's basically the idea, and that's pretty much it. Yeah, and I didn't explain this one, but it's the same thing, same idea. You upgrade it to the target, so you have this left over and you have this thing, but pretty straightforward, right? Okay, yeah. Well, it's straightforward if you understood everything else, and that's pretty much it. Yeah, I'm gonna make this smaller so you can maybe see the whole screen. Okay, maybe not, but at least you see all of Go, which is my function for calculating for a given target. And that's pretty much it. I think there are a couple of things, right? The hard part is, well, in this case, what is the complexity? I think that's the trickiest part. And honestly, during the contest, I YOLO this part. Or like I have a sense, I have an intuition, but I didn't prove the bounds, honestly. So when I submitted, I was like, okay, well, let's hope it works. I mean, that's pretty much it. And luckily, it did. But yeah. But the key thing is that even though leftovers can go to 20,000, if you kind of follow the logic so far, not all of them are reachable, right? Because, like, this could be a specific number, this has to be a specific number, and it could be 0, sure, maybe we have extra zeros even, but that's it, right? It could be 0 and maybe 3 different numbers, because you don't ever use the leftovers, right? Because we don't ever use the leftovers, then now leftovers can only be 3 numbers, and you have 26 times 3 or something like that. It is very good, right? Because, yeah, for a given target, leftover can only be 3 numbers, right? And maybe even 2, because I think it's just 0 and one of these, but not both, right? So as a result, this is just very fast, right? Yeah. Okay. And I think one thing that I would say is that if you look at upgrade, and now that I think about it a little bit more, I didn't do this during the contest, obviously, is that upgrade is equal to delete with free upgrades. That means that you always want to upgrade and then just retroactively delete it, if you want to call it that. Because kind of, if you kind of match, if you copy and paste this here, say, right? And then now you kind of match up the if statements, right? And then you kind of write this here, and then write this here, and then move the thing, right? And then now you can see that side by side, this is always going to be a better result, right? Because you just have 3 upgrades. So then now you can actually remove this, and then this is a very standard problem at this point. Yeah. Well, no, it's not that standard. I mean, but you can see that because now with leftovers, because we don't care about it, for every input, for every given target, it can only be 0 or either current or current minus target, right? So that means that leftovers can really only have 2 different values, is what I'm trying to get at. And because of that, this is fast enough. This is just 26 times 2 times 20,000, and we are good enough. And that's pretty much it. That's the idea. I'm going to submit this actually. That'd be funny if it's wrong. I just want to see if it's faster. So let's take a look at the. I mean, it should be faster. But yeah, you can see that it reduced. Just having that one, removing it, gets it down to like 1 sec, like by 0.4 seconds, 40%. So that's pretty good. And yeah, and that's pretty much it. That is all I have for this one. I'm gonna make this smaller now. Hopefully you can see more of it. Okay, maybe not. But oh, I also have this function. I talk about this in the live portion of the video, but it's just to make this a little bit faster because min by itself takes a variable array function or variable parameter, if you will, and it does magic with it, but that magic costs time. So if you kind of make it so that it's just an if statement, it will be faster. But yeah, that's pretty much it. That's all I have with this one. Let me know what you think. I think the ideas are very cool. The leftovers or the freebies are the expensive part, or like the hard part to think about. But once you get that, and I was fortunate to kind of work it out and then see it, because when I started typing it out, I actually didn't see it that way. I was trying to be like, okay, you know, I did the math, and then it just took me like while I was writing this code, I was like, oh, actually, you never want to. You know what we just said, but you never want to change. You never need to upgrade more than twice, or even twice. So then that simplifies the enumeration of the states, right? And then once you do that, then you could prove the states even easier, right? Yeah, because if you trace this, it can, like I said, only be 0. The target is a constant, and current is also a constant, given the input, right? So everything is constants. So there are only 2 things, and that's pretty much it. That's all I have with this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live during the contest next. And I try to optimize. You could also watch me like do some optimization going from 1.8 to 1.5. We made one more at the end. So yeah, that is all I have with this one. Let me know what you think. Thanks for watching. And you can watch me solve it live during the contest now. This is ridiculous. But okay, fine. Okay, let's just do Q4. Focus. You have, I mean, only 3 people got it, so it doesn't look so great. We have, or 6 people got it or whatever, so it still doesn't look that great. Very smart people. But okay, we have, I'm just trying to find a timer actually. 47 minutes. Let's go. How many people got it in? I don't know if okay, 20 minutes maybe. That's fine. All right, let's just focus on being good and not worry about meta. Okay. String S, T is good if all characters of T occur the same number of times. All characters of, okay. Try to find an order. I think I should finish reading it first. Okay, delete a character S, insert a character in S, change a character in S to the next letter in alphabet. Okay. Excuse me. 10 to the 24, 10 to the 4, 2 times 10 to the 4. Okay. I don't know how to do this, just to be clear. What is 2? 1, 2, 3, 4, so 20,000. So n square may be too slow for DP for sure. Only 5-6 people got it. Oh, operation's good. Okay. Okay, so I mean, the first thing is to notice is that the characters themselves don't matter, so you have a counter, right? We can delete, we can insert, but the characters itself don't matter. So, I think it's just brute force on the characters. 20,000, so at worst is 20,000 times 26 number of characters, right? So that means make everyone unique in that way, right? Okay, so let's see. We never want to, okay, so yes, so counter of S, right? And then mx is equal to C dot values, so max of this. So this has 26 things, right? So then now maybe we can do something like yeah, right? So something like that maybe. I don't know. Structurally, I don't know how this. The go function is the magic question mark function, right? But especially with the change a character thing. So okay, so then now we can add, okay, right? So it would go target, index, and carryover. Okay. Well, no, was carryover enough? Carryover could be up to max, so it's 20,000. Do we always want to be greedy? I guess so, right? Do we always want to be greedy? But also it may be 20,000 square, which is not fast enough. But the costs are ridiculous. It wouldn't make sense though. So okay. So the key thing is noting that the third operation doesn't make sense to use more. If we do it from small to large, it doesn't make sense over two things. So then the previous will only have. So you never carry over a certain amount. Because it would never be optimal to, I mean, or it'll be exactly the same as adding and then removing anyway. So the extra ones don't matter. So you have to delete them. So it's either delete or carryover, and it's from the previous one. Let's sketch this out. I don't know that I know how to do this one, but yeah, let's sketch this out. Let's just say index. The target is the target. Let's say for cache here, right? Yeah, so we have the index, and then leftovers, and that's it, right? What else is there? Yeah, maybe that's it. I want to convert this to characters or numbers, so let's just say right. Let's just take a look, make sure that this is what I expect. Okay. 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 Honestly, I don't know that this is good enough, but I think it's worth YOLOing maybe. A lot of people have only one penalty, so it's not even. I don't know. Maybe it's obvious. Maybe it's not. I don't know about this idea though. Okay. Right. Yeah. Okay. So index is equal to 26. Then we're good. yeah, the leftovers are 3, which is also good. How much can we max it by? Can we skip it? Okay, well, I don't know. But yeah, so then now, let's see, right? Then now we have tick, no tick, right? So yeah, with the target, right? So tick, or not tick, no tick. Delete, insert, or leftover, or upgrade, say, right? So delete, what does that mean? So if we have if C of index is, maybe I could convert this to an array as well, just because this is whatever, but okay, if this is greater than target, then we just have go to index plus 1. We have to remove the difference. No, that's the leftover array. So this plus minus target is the delta. So that's one way to delete it, right? And when we delete, then you have no leftovers. So okay, so that's one way. But you can also delete to 0, right? So I guess this is an else, because you wouldn't do both. Also, you would have 0 left over, plus C of index. Okay, right? Okay, I think those are the deletes, right? And we don't have to use leftovers because, well, we wouldn't, right? So if C of index is less than target, then best is equal to min, best go to, well, let's see. How do I want to write this, right? So maybe current is equal to C of index, right? Let's write this way. Okay, so then now insert. If it's less than target, then we go, well, index plus 1. We will have no leftovers, plus this is the naive one, but I think we can actually add the leftovers here directly because we get them for free. So then it's just this thing, right? But it could be negative, so we don't want negative, so we want max is equal to, right? Okay, so this is insert. Yeah, and then upgrade is just oh yeah, it's basically delete, really. We only want to upgrade if current is greater than target. Greater than target. I think I missed a thing. Okay, if current is greater than target, then we want to upgrade. So same as delete, maybe. But because we upgraded, this will be 0 plus. Oh no, this is upgraded. So current minus target is the leftovers, plus current minus target. We can also upgrade to 0. So yeah. So same idea as the other one as well. Just current then, right? Okay, let's see if that works. Oh, well, you should probably call it, right? So R is equal to 0, 0. Something like that. Well, 0 is probably not the best answer for this, but that's okay. When I go I, 0 causes 0. That doesn't make sense. The target. Target being 0. That's weird, right? We have 25 minutes, about 35 minutes left. I don't know if I'm making good time, but we'll see. 0, 0 is definitely wrong, right, for the last one. 1 is actually maybe right. Oh, no, I'm looking at the wrong one. Wait, this isn't the... Did I accidentally put in a B or something? This is where like they have a bug, because this example is not the same as their example, which is kind of funky, actually. That's why I was like, huh, I don't know. Leetcode. Don't know Leetcode. Okay. So 0 being 0 is a little bit awkward. Why is 0 being 0? So target... So this goes over 26. Do I need all 26? No, I need to skip some stuff. Right? So, okay. So current is equal to target. If current is equal to target, what happens? Nothing, which is really weird, right? So if current is equal to target, then we can just do... Then we're done. So then we can just... best is equal to min, best go to index plus 1. And then we have no leftovers, because we don't care about the leftovers. But that's still not right, and it changed the other answers, but not this one. Am I not querying the cache? Well, no, it's the first one, so what is going on? Alright, well, let's print it out. Print target index leftovers best. Okay, so why? Go I, right? The target for 0, target index leftovers best is... Why? Why is these all zeros? So current is always going to be equal to target, so then you have these things. Oh, I am dumb. I'm just missing a parent. I have a parent in the wrong place for that one, for upgrade, so I guess that's why. Okay, yeah, whoops. Maybe that's why, I don't know. Well, it gives me real answers, so that's nice to see. Oh, we'll print out this one's fine to print out. Okay, 1022. I mean, am I ready to submit it? I don't know. Probably not, honestly. Because we have to do something like s is equal to a times or something, right? I guess this is the slow one. I don't know how much of that is because it only does one character, so we'll see. Yeah, okay, YOLO, let's give it a submit. I mean, that may not be the worst case. I don't think that's the worst case, honestly, but okay. 20,000, I don't know that I could prove the bounce more though, and I feel like this could time out if I'm 1.8 seconds is actually pretty fast, but I feel like in a whatever it could time out, so I'm kind of scared. But I didn't think this was that hard, but yeah. What did I fix? Was it just this? Oh no, I just fixed this one because it was just basically always returning 0 here. That's why. Okay. Okay, if I didn't have this, it would just give me like bad answers, right? Because I think that's the... that's actually interesting. Oh, because... Oh, because it just doesn't do... Oh, it just skips the case where this is true. So, okay, so I mean, I needed to fix that anyway then. But... oh well. Hopefully this lasts. We'll see how it goes. But, I don't know. Whew, 29 minutes though. So I mean, look, all right, when you finish 11th, how can you be not happy? I don't think I could be that much faster, honestly. But I don't know. I'm so also I'm like it's done per se, but I'm also trying to think about like I don't know that this is not challengeable, right? That's what I'm saying. Like I'm trying to I don't even know if I would call it upsolving, you know, because I'm just not confident about this. The thing is that it's just the number of states for leftovers. I guess the number of states for leftovers is not 20,000, right? I think that's just like the max number, which is not the number of states. And for 26, I don't know that you can do like a 2 to the n thing because you only. Oh, I see. Well, I think because of the leftovers thing, like I can't prove the bound honestly, but I think it makes sense in the sense that the leftovers, um I guess I could see it only in the sense that the leftovers can only be the number of things from the previous one, right? So I think that's the key observation. I think everything else is kind of like I need to think to. Okay, let me actually ask ChatGPT. Can you give me a string, a random function to generate random string of length n? Okay, right. Because I feel like I do. So 1.7 seconds for this case. So like I don't know. Can this be challenged? Yes, right. So that's why it's just scary. Why is this so? Why does this take one? I think it's just a lot of function. I think it's just this function. Can I go down a little bit more? Do I need to be? Like, is there some median finding thing that I can do to make it a little bit more efficient, right? Like, I don't know. Oh, in Python, it was generating 7 Java. But yeah, I mean, didn't hit top 10. Would have been nice if I hit top 10, but don't worry. I don't really worry about it. If true. Yeah, I don't know. Honestly, it's not. Oh, what? Just give it to me. Okay. Right. Okay. I just want an example. Like I don't know that. Like I don't think that's the worst case. It's why. Right. So okay. So I have this thing. Right. So that's. Okay. What? It's just here. Did I misspell it? I mean, that random strings are super fast actually. I think it's because I iterate on max, so that's why. I think maybe as a cheating thing. Okay, so even if they're 2 characters, let's see, if they're 2 characters, you wouldn't. It's tough because yeah, I think there is some like cheating thing that I can do just for fun, right? Like yeah, like if length of c is equal to 1, then we just return 0, right? That would make it like really fast for sure, right? Like I'm not gonna lie, I am gonna submit that just to be clear. Right. And also if yeah, if it's already done, then also return 0, right? Yeah, so let's give it that a submit. Yeah, I mean, I'm just a little bit cautious. Actually didn't change anything, so I guess the inputs don't have something crazy. I think the thing is that like if you have 2 characters, right? Like most of them are not doable, so you can save some skill there. But these functions are also like not super expensive because But I don't know. Maybe that's not true necessarily. But these are like, yeah, like someone told me how to do what's it called? F min is equal to lambda xy. If x is less than y, then x if else y, right? Does that work? Okay. Someone told me this about this tricks because the reason is because min is it takes an array element, so it actually is, you know, a little bit slower. So we can maybe YOLO submit again. Just to kind of let's see if that changes anything. But yeah, so you see that like it's a decent sized chunk, right? 0.2 seconds. So I just wanted to make sure. Yeah. Can I do? I mean, these are some obvious things. Actually, I forgot to do F max. Fine. I mean, I think that's fine though, because we do so many more things here. But the reason is because max takes oops. Awesome. Min and max takes like an array, a variable parameter type thing, and that's why like. Yeah, I'm just curious. I don't think it changes that. Oh wow, that actually does. Maybe that's just a little bit fluctuation though. I don't. That doesn't sound realistic, like on this one thing. But because it takes a whatchamacallit, it takes a variable parameter. So then Python does a lot more magic to try to parse that. I wonder if this changes anything either. Maybe. All right, I'm done with testing this. I think one more thing I do want to do is actually maybe convert this to Java, but maybe that's too. I have 2 levels of whatever, so maybe that's a little bit too much. So I think I'm fine. 1.6 seconds. I mean, if Leetcode is going to yeet me on this, then it will be sad. All right. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, this explanation, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.